Okay, so in this video I'm going to teach you how to, I'm going to demonstrate how to teach homeostasis, and don't just parrot this, right? You should make this your own, right? So the first thing, okay, I'm teaching about homeostasis. And first let's just define this, right? This is the capacity or the ability to maintain a consistent internal environment. Okay, despite changes in the environment outside, the ability for us to maintain a consistent internal environment, right? So what are the parts? How do we do this, right? Well, there's lots of different homeostatic systems, and all those systems have these parts in common. There's going to be some kind of stimulus. Okay, maybe that's a temperature change, or maybe you're losing blood and your blood pressure's dropping, or maybe you're sick and that's causing some kind of stimulus here, right? Well, that stimulus is sensed by a receptor. Right? There's going to be some kind of cell or protein in the body that can measure this stimulus, that it's changing. Okay? Then that receptor, through what's called an afferent pathway, and notice I'm not using any notes here, right? I'm testing whether I know this myself without my notes, right? So this receptor, through an afferent pathway, sends this information from this stimulus to a control center. Now this control center could be the brain, and most often is the brain, right? But it could be other locations in the body, right? Other structures, okay? But often it's the brain and parts of the brain. Now the control center then measures kind of, okay, we have this information coming in through this afferent pathway about this, from this receptor about this stimulus, and it's going to compare kind of where this, whatever variable, blood pressure or body temperature or levels of sodium or calcium or whatever, where it's at versus where it should be, right? And if it's below, let's say this is where it should be right here, if it's below that, it's going to do something to try to raise that, right? And if it's down below where it should be, if it's higher than it should be, it's going to try to raise that variable, or it's going to try to lower that variable so it comes back down to normal, right? So it's going to try to do something to bring it back towards what's called set point, okay? So that control center will send out information through an efferent pathway, okay, to what are called effectors. Okay, the effectors are the things in our body that can change that particular stimulus, whether it's blood pressure, body temperature, levels of sodium, right? The things that can affect that, okay? And then the effectors lead to a response. So let's do an example in the book, but it's good to try to figure out other ones. And then maybe we'll use an example of like how a thermostat works in a house or something like that. Okay, so let's draw a little graph like you have in your teaching sheet here. And let's just do blood pressure. Okay. So blood pressure is a controlled variable. It's something our body's monitoring, which means it has receptors for it. Okay? And so then this blood pressure, it has a set point, a point where the body's trying to keep that pressure. And then it has a range. This would be called kind of this range here would be your normal range. Let me see if that's still on the screen. It looks like it is. Normal range, okay? And so let's say your blood pressure starts out, we'll pick a new color, we'll do red. Let's say you start out here at your set point. But let's say you have a test coming up and you're feeling very anxious, your heart starts beating hard and fast, and so your blood pressure kind of goes up, right? Well, that's your stimulus. Now, you have receptors that sense that change in blood pressure, right? You'll learn this in Bio 265, right? You have sensors in your carotid artery and in your aortic artery that sense this pressure, okay? And they get stretched by this pressure. And that information from those receptors gets sent to the control center. In this case, it would be your brain, right? So stimulus, let's say it's high blood pressure, right? The receptors, these are called baroreceptors in this particular example, but you could just call them blood pressure sensors or whatever, okay? Then, through some neurons, or let's say just nerves, through afferent pathway, it talks to the brain. Again, you'll learn this in Bio 265, but anyway, talks to the brain, and the brain says, okay, blood pressure's here, it's too high, where it should be here. So what are we going to do to lower it, right? So it's going to send out again, through nerves, information out to effectors. Well, what would be the effectors here? Well, this would be like your heart, and it would be the muscles around blood vessels, right? And what do you think it would do to the heart, right? Well, it's going to try to lower its beating, slow it down, so then the pressure will come back down, okay? And blood vessels, right? If they're squeezing really hard on the blood, the muscle around the blood vessel, they're squeezing really hard on the blood, that would cause the pressure to go up, so it's going to cause those to relax, right? And the response then is a drop in blood pressure, okay? So you saw here, this pressure went back towards that set point. Let's do another example using blood pressure again. Let's say you're sitting down and you get up really fast, and because of that, your blood kind of pools downward in your body because of gravity. Well, that would cause your blood pressure to drop, okay? So your blood pressure drops. So now instead of high blood pressure, it's low blood pressure. Gets sensed by these baroreceptors. It sends information to your brain through these nerves, and your brain goes, okay, my set point's here, but my pressure's down here. What am I going to do? What information will I send out to tell the effectors to bring that pressure back up, right? So it sends information to the nerves, to the heart. In this case, the heart's going to beat faster, and the muscles around the blood vessels are going to squeeze in on the blood vessels, right? And that would then cause your blood pressure to come up, right? So it'll come back up. So now we brought it back up. Now in both cases here, when your blood pressure was high from being anxious and coming back down, or it was low because you stood up too quickly and brought it back up, these are both negative feedback. Even though one's going down and one's going up, they're negative because they're negating the change, right? You're going away from set point and it's negating it back towards set point, okay? So that was negative feedback. Now let's imagine a positive feedback scenario with using this example, right? So let's say you're in a terrible car accident, you're bleeding profusely, right? And so here, your blood pressure's way down low. So it's way down here, okay? Well, low blood pressure, baroreceptors would sense it, those blood pressure sensors. They send information through nerves to your brain, and let's say your brain then, what it should do for negative feedback is increase the heart rate, activate the muscles around the blood vessels so they start squeezing. But what if they did the opposite? What if the heart slows down and these blood vessels relax? Well, that would then cause the blood pressure to drop even further. Now, why would they do that? Maybe because you've lost so much blood, there's not enough blood to keep them alive, right? And so they're moving away from set point, right? These effectors are essentially pushing this away from set point, okay? So whether that's downward like here or upward, right? Positive feedback is adding on to the stimulus. It's increasing its movement away from set point. Negative feedback moves it toward, the effectors are trying to move it towards set point, okay? So that was just a quick example of how to teach a teaching sheet, right? I only took, how long was that? 9 minutes there, right? When you teach this, come up with new examples, like how's the thermostat work in your apartment or house? How does the cruise control work? How does temperature is one your book talks about, right? Go look up on the internet different examples of homeostasis and try to teach that. How about controlling blood sugar in your body, right? Look up those different examples and see if you can figure out how to teach it somewhat like this.